Well, today I'm going to be giving you guys a rundown on the kind of stuff that is being done to try to make cars safer to drive, and this is going to be leaning towards self-driving cars and stuff like that. You know, those buses, those little mass transit systems that drive around that are electric are not like electric cars. They are basically operated using from a central location. And a lot of times, the way I understand it, they're using satellite technology to guide these things. They won't go but about 15 miles an hour, and they have these little stops they stop at, and they run about 6 hours on a charge or something like that. And those aren't necessarily a bad idea. But whenever you think about these electric transit things that are running, kind of like the thing, the train, if you've ever been to the Atlanta airport, you know those trains, they run a lot faster than 15 miles an hour because they'll just about throw you down if you're not holding on to something. But the simple fact is the mass transit stuff is working toward being operated, you know, by these operators from sitting at computer consoles. They're almost like drones that roll on the ground that stop and pick people up and that kind of thing. Anyway, it's an interesting bunch of technology. But systems designed to prevent accidents and compensate for driver error, which there's a lot of driver error, are becoming more common. They're basically, back in the day, you used to have to know how to parallel park, and on most cars nowadays you still do. But there are cars out there that they're making that will parallel park for you. They're trying to dumb everybody down so the car will do all your thinking for you. And these safety systems can be damaged, though, on these cars that have them, and there's a lot of safety systems already on these cars. But during routine service procedures, you can cause problems. Now, one specific example of something you don't often think about is that it's against federal law to disable, for example, the tire pressure monitor system. If the tire pressure monitor system comes in working, it's supposed to be working when it leaves the shop. Now that can be kind of dicey. I have seen times when we would go to fix a flat and we'd go to break the tire down, and we would be very careful not to damage the sensor. You know, some of these GM sensors have got this rubber stem on them and all that, so you can't just take a nut off and get them out of there. And we've actually seen those, you know, where somebody's in a big hurry and you go to fix a flat, and when you put it back on there, suddenly that sensor won't talk even though you never touched it with anything. And so we ordered another sensor that was supposed to work from the parts store, and when we put it in there, it was putting out according to the TPMS tool, but the stupid thing wouldn't talk to the GM electronics on the car. I mean, there's just all kinds of stuff. But it's illegal to, if a TPMS system comes in to your shop working, it's illegal for you to put it out with that TPMS not working. So that's something that you can look that up. I looked it up when I was doing a presentation on TPMS for my students. Well, these systems here have computer control inputs and outputs. You know, they got yaw sensors and all that, and they're looking to see what's around them. And they actually have some limited control over the brakes and the steering and stuff for collision avoidance and stability. What you're seeing right here is an example of what you'd call understeer. And it's understeer and oversteer are kind of confusing. Oversteer means when it turns more than you wanted it to, and understeer is basically when you missed a curve. Somebody correct me if I'm wrong about that. Well, on a curve and road, a forward-looking sensor needs to have a wide field of view, and the sense vehicle position needs to be confined with road geometry, like a curve or whatever, to know whether the lead vehicle is in. See, like if you're behind a vehicle and it's going around a curve, then your vehicle needs to be sharp enough with the way that the electronics are designed and the visuals so that it can tell if this car is going the other way and it's going around a curve. If it's over to the side going around a curve, it may, you know, it's easy for the system to get confused and think the car is in another lane when actually it's in your same lane, but it's going around a curve. So that's really important too. Now, the objects in the field of view, which is signs and stuff like that, is considered clutter. This is stuff it's not really, it's not going to be moving, it's not going to do anything you don't expect it to do, but it's stuff that has to be, whenever the system that's on the car is looking around to see what's out there, it sees this as clutter, and it doesn't watch it to see if it's going to jump out in the way of you. All right, the adaptive cruise systems are only concerned with vehicles. They basically, anything that's stopped, a stopped vehicle or signs or any things that's beside the road is considered clutter, and the adaptive cruise is only watching the vehicle that's in front of them in the same lane. But at the same time, it needs to be watching in a sort of a fan pattern, so because of the curving of the road. A lot of the stuff has got to be factored in on this kind of thing. All right, lane departure warning and keep assist systems. You can get these things. This is a system that I saw that you could buy on Amazon. And it's evolved to the point where the car corrects course if it reaches the lane markings. And you know, a lot of the times, if you think about this, they have these little ridges on the side of the road now for you. If you're drifting over there, you'll be running over. They'll either have these little markings on the in the lines in the paint that makes the tires whine, like whenever you run over them. And if you run over one, the dotted one, it goes, you know, like you can tell if you're which way you're going just by listening. And if you're sort of getting a little sleepy and you start to go off the road and you run over those bumps outside the white line on the pavement, it'll wake you up and make you realize, hey, I'm off the road. You know, it's sort of natural to want to get away from all that noisy racket that's going to be made when you're doing that. But the corrections are subtle whenever you got a system that's watching the lines. And of course, the thing about it is, if the lines aren't clear, you got issues with that. And also, if there's snow or something covering them up or dirt, you know, you might run into something like that. Like after a dust storm, it may cover up all the lines on the road, and then the system doesn't even know where the road is. So there's issues with that. Now, the passive warning systems use lane markings as a basis for their calculation. Now, rain and snow, like I said a minute ago, will impact the markings too. And that add-on system is pretty cool if you want to go with something like that. Radar is a good choice for seeing big metal objects. And the approved frequency is 77 gigahertz unless they've changed it. It works at the speed of light, so sensing is almost instantaneous. Simple radar is like a single spot with no information on bearing or angle. Now, they sweep the beam mechanically if they're more sophisticated, and they use 2 or more beams and different processing schemes in their algorithms to measure bearing and range. It's a whole lot easier if you have 2 inputs, and I'll talk about that again in a minute, to tell how far away something is. Just like your eyes give you depth perception, and your ears basically can tell how far away something is. But resolution is like 1 meter in range and 3 degrees in bearing. Now this is granted, this is an old image on the bottom there from 1995, but if you look at basically you're seeing what the radar sees and how it identifies objects. And this, you look at the picture on the top there, you look at this picture on the top, this is the same thing as being seen on the bottom. See that? And so it's basically it's looking at these to try to determine. You can see why this is not a really good system. On the newer stuff is better than this, and we'll talk about that again in a minute. But the range and the bearing is up, down, left, right. Brightness indicates the strength of return. And it's in LiDAR, and laser rangefinder refer to measuring distance. And radar and this stuff is the same way, because even radio waves are nothing more than light waves. So if you're shining a flashlight back and forth, and you see stuff out there that light is hitting, you know, the image is it's reflecting back to you, you can actually see it. That's one of the reasons that stealth fighter planes and stuff like that have got these angles that make sure that anything that hits them is angled away from whatever's looking for that to come back. But LiDAR, and laser rangefinder, they're looking at measuring distance using the travel time of a laser beam. And it can be scanned over the scene with mirrors to produce a range image. And it can be focused on small spots. You can read the words. I'm not going to read all the words to you. But you can see kind of how that works. Now, instead of sensing a blob with radar, LiDAR can make thousands of measurements. Now, I got this image I got this little piece of video from Velodyne LiDAR. And as it scans, it can measure the fine details of shape. It says LiDAR is near visible light. It's blocked, though, by fog, snow, and heavy rain. So if you got fog, you got snow, you got heavy rain, this is not going to work as well as you see right here. But you're getting a little bit higher resolution picture here than you were with the radar that I Now the top picture shows reflectance data, and that's the amount of laser energy returned from the point in the scene, and is roughly equivalent to a washed out flash photograph. The lower picture is range data. Brightness indicates range. Points farther away are displayed brighter, so the closest stuff is displayed darker. Now, this is just a real quick run through this stuff, so you're not going to get a whole lot of information right now on, you know, how you put the wrenches on this stuff, but I'll talk a little bit about that later. Sound travels slower than light through air, so sonar is not all that great. Sonar is only good whenever you're just a little bit, I mean just a short distance away. But sonar hardware doesn't cost much, and it works in most weather conditions. Even if it's raining or something, it still is basically going to get a bounce back from the objects that it sees. Sonar is commercially available for blind spot sensors and backup warning sensors and that kind of stuff. You've seen those on cars before. Road obstacles, you know, highway patrols. Look at all this stuff. Appliances, ladders, pallets, deer. A survey commissioned by a company that builds litter retrieval machines reports 185 million pieces of litter per week. That is a lot of litter. Now, personally, I don't throw stuff out beside the road. I mean, I may spit out a wad of gum or something like that, but I try to spit it out where nobody's going to step on it, right? Rural states report up to 35% of all rural crashes involve animals, mostly deer, but also include moose and elk as well as farm animals. You probably heard this funny story about this woman that called the radio station because a lot of people were hitting deer down there. There was a deer crossing sign there, and a lot of people were hitting deer on the highway, and she called the radio station and she said, we need to move that deer crossing sign somewhere else because too many people are hitting deer down there. Apparently she thought the deer were reading the sign and crossing the road there, but anyway, go figure. But there's carcasses, mufflers, deer. I had to put a transmission housing, replace the transmission housing in a Cadillac Eldorado that hit a muffler while they were driving down the road. It busted the transmission housing. There's all kinds of stuff you can hit. There was one guy that Paul Harvey was talking about that hit an old bumper jack. It was laying in the road, you know, one of those with that long toothed piece on it from back in the day. And that thing came up through the floorboard and went through his stomach and killed him. So stuff laying in the road, you got to be really careful about it. I try not to run over a box or a bag or something like that because you don't ever know what's in it or what's around it, you know. Now, at one time I popped over a hill and on a country road and was meeting another car, and somebody's big plastic trash can was sitting in the road, and I ran into that, and it, you know, kind of messed the bumper up a little bit on my Explorer, and I had to do some work to straighten that mess out. That was real aggravating. But see, sometimes you just don't have time to dodge. If I try to dodge the trash can, I'm gonna run head on into the car that's coming. So it's just, you know, things happen so quick. Animals will just come out of nowhere sometimes, and you'll hit them, and so on and so forth. Now, LiDAR in a high-resolution scanning is useful for seeing even little objects. The variants to use reflectance channel of LiDAR and look for bright returns which come from objects or people on the road. And so that's a pretty good system right there. And you know, this stuff's been in development for a long time, 35 years or something like that. And they just keep working on trying to improve it. So here's the rise of the machines. You notice right here you got a lens, you got an image sensor, and this you got this same setup on both sides. And then the video signals go to the processing, and then basically the read-only memory and the DRAM recognition, microcomputer processing. You know, you basically are looking at all that. And then you've got your CAN bus right here, and so on and so forth. You know, there's a whole lot of stuff you could talk about that. I'm not going to spend a lot of time on that. But stereo optics using a system like this works by finding the same point in two or more cameras, intersect the lines, kind of like, you know how Doppler works? Doppler is basically when you look back and, you know, like blinking one eye and then the other to see how much it moves back and forth and all that. Doppler radar kind of works like that, and it measures it as it's coming closer by taking multiple images of it, one and then the other and all that. This one here is looking at them both at the same time, so it can determine, or it may be flashing back and forth sometime, I don't know, but the simple fact is it's looking at from 2 points. It's got them spread far apart on either side of the car so it can get an idea of how far away something is, and it can make better decisions. Now, stereo visual guidance is low resolution stereo. See this right here? See, you got this woman here, right here. Okay, this is the original image. All right, and this right here is the depth map from the stereo. Brighter is closer. See, so if this is brighter, it's going to be closer than that, and if that's brighter than this, it's going to be farther away. So it gets an idea, sort of a three-dimensional idea of how far away something is. It doesn't give you a picture of the woman, it just sees the shape of something there. See, that's how that basically works. Now the objects on the road, on this long-range stereo, it's actually able to see a fairly good amount of detail. This is what it's seeing. I mean, this is what it sees down here, and this is what's really there. And you can see how these correlate. The detected objects are in black. You know, besides obstacles on the road, it's found a person, a sign, the grass, and a distant dip in the road. It's pretty cool how that works. I mean, they got their acts together on that. Now, sensing lane position, you know, recognizing lanes is necessary for automating guidance and for lane departures. If cars aren't staying in their same lane, then you're going to have issues right there because it confuses the system. You know, for rear-end collision warning, you need to know which lane you're in and which lane other vehicles traveling in. And so the University of California, and this, I think this was a while back, a pretty good while back, because it's hard to find much of anything about this online anymore. But they suggest they love to work with magnetics at the University of California, Berkeley. If you look up University of California, Berkeley, you're going to see all kinds of stuff about them using and developing magnets and stuff. But they suggested burying these magnets in a road. You see how they bored this hole right here, and they basically are they're putting these magnets, these things down in the hole, and they're sealing it up. Well, you got this magnetic, you know, if you put magnetometers underneath the front and rear bumpers of the vehicle, picks up the magnetic fields for input, and you can see how that would work. Now, it'd take a while. Doesn't cost a whole lot, these magnets don't, but, you know, boring that hole and putting them in there can take some time, but once you get them in there, they're in there. And you got also efforts to place magnets in lane parking stripes. You know, magnets are not affected by snow and ice. That's another plus. It don't matter if you cover them up, that magnetic field is still there. You know, the cutouts that you pull up on that change the traffic lights, those basically are a wire that's running in that cutout, and they're running a little bit of current through it, and they're basically measuring for that to deflect when a big metal car pulls up over that cutout in the pavement. Then it sends a signal that tells the light to change or whatever, or the fence to open if it's something like that, you know. Radar reflective services, you know, you got collision avoidance radar that can be used with lateral control and using lane marking tape. You know, 3M likes to come up with stuff like this. Frequency dependent tape properties can provide distance and other information. And so that's what you're looking at right here. You see that little thing in the middle of the car looking at it. Now, vision-oriented system for lane tracking, the detected position of the solid line is shown by the blue dots. So you got light blue dots, you got dark blue dots, and the data from other sensors is visible, showing the location of radar targets, yellow X. It'll have, there's some vehicles that's got several different things on them. Cameras, radar, all that. Infrared spectrometers can be tuned to detect wet pavement and stuff like that. Now, you know, it might be difficult for it to see sand on the road if it was just a sort of a light sandy, you know, and that can basically cause you to lose it too. Or what about the grass from somebody mowing the grass and throwing that grass out there? You know how if you're driving around a sort of a sharp curve and you're going a little too fast, you can actually get on some, if there's a lot of that grass on the road, of course it's going to cover up the lines and stuff too, you can lose it on that grass. Or if a truck turns over, like this has happened over here close to where we are, there was this truck that turned over and spilled an entire trailer truck load of eggs, and they busted all over the road out there. And the cops had to stop traffic and throw sand out there all over those eggs so that people wouldn't lose their traction on those slippery eggs. But roadside mini weather stations can have sensors built into the pavement, and vehicle dynamic sensors can detect the slip of the driving wheels and so on and so forth. You know how the yaw sensors and that kind of thing will basically tell you, operate the brakes to straighten the vehicle up if it starts to slide a little bit. My Explorer has that, and it's a 2006 model. Now, system level solutions build safety into the system by considering the entire system. You know, in automated highways like the California, you know, they're really big into this kind of thing. California doesn't trust their people to know how to drive, so they basically want the cars to basically pretty much be driving themselves, and they're going to have a platoon of cars running, you know, bumper to bumper, because in that regard, if somebody, you know, if there's a crash, you know, the car's not coming from a long way behind to hit. You know, anybody that has driven in Atlanta or one of your other big cities, you'll find yourself sometimes driving 85 miles an hour about 10 feet from the car in front of you. And if you try to slow down, somebody stuffs another car in between you and that car in front of you, because it's just like too many rats in one box up there or something like that. They're kind of looking at this, or you know, they're having the cars driving along real close to one another. If something happens to one of them, it's like boom, boom, boom. The cars aren't hitting very hard because they're not very far away, in theory. But you know as well as I can, when you're driving those cars like that close together, you can have a pile up before you know it. So anyway, if your eyes are closed and you're driving, and this has been on cars for a long time too, it's watching your eyes, and it's looking at the light reflecting off of your retinas. And if it sees you close your eyes, it will make an alarm and turn on a little coffee cup. Some of you've probably seen cars like this, but it's basically looking at your eyes. When your eyes close, you know, it's not shining off your eyeballs anymore. And there's probably other, you know, stuff that's doing that now too. Incidentally, you might have seen that Biden just signed a piece of legislation that's geared toward putting kill switches in cars, so that if they had the idea that you're driving drunk or something, or you're swerving all over the road, they can shut your car off, you know, so that you can't, so that you have to go off by the side of the road. Now that's going to be really, that's going to be really dicey if you're driving in traffic in Atlanta and it decides to do something like that. You can imagine what kind of pile up that would cause. A lot of this stuff they're doing, they're not thinking it through very well. Well, you might be working on this stuff. These safety features and all the other ones are going to have to be regarded carefully during routine service operations. You can dislike them all you want. I'm not a big fan of electric vehicles. I don't mind hybrid vehicles so bad. Now, replacing a battery can be pretty high. But back in 2016, there was a guy that contacted me when I was teaching over there, because I had gone to Craig Van Battenberg's hybrid school, and Craig had our school listed as a qualified hybrid repair facility. And there was a guy with a Chevy Volt that called me, and he said that he had bought a used battery from a Chevy Volt that had been in an accident, and it cost $12,000, and he wanted to know if we would put that battery in there. And I was thinking, boy, this guy right here has got it bad. He's got a car that's 3 or 4 years old. It's not under warranty. The battery has crapped out, and he's looking at $20,000 at the time to replace the battery at the dealer, and he found a $12,000 battery that was used. He was trying to find somebody to put that in. There was another guy that contacted me from about 100 miles north of the school, and well, his wife did. She called and she says, my husband has bought a replacement engine for our Toyota Prius, but he can't find anybody to put it in there because all of these shops are scared of working on hybrids, and they don't want to put the engine in there, or if they do put it in there, they're wanting $2,500. But he only paid $325 for the engine. And I said, what does your husband do? And she said, he works for the power company. I said, well, he understands high voltage and all that. She goes, oh yeah. I said, has he ever worked on cars very much? She goes, oh yeah, well, he put a water pump on this one a few years ago. He can work on a car. And I said, have your husband call me back. And this guy was about 60 years old. So he calls me back, and I says, what you need to do is get out there and pay attention to how that thing comes apart. Take that motor out, put it back in. You can swap that engine out yourself. You don't have to pay somebody $2,500 to do it. And so he called me back the following Monday. He said, I did that on Saturday. It didn't take me but about 7.5 hours to do it. Easiest job I've ever done. I can't believe they were wanting $2,500 to put an engine in his car. Anyway, that was kind of funny. But see, the thing about it is this hybrid stuff, the batteries, if you can find a good battery, you know, they got rebuilt batteries that you don't know what they're going to do, and they're super expensive. And changing the batteries out is not usually all that difficult, but there's a lot of other little things. The batteries have chalky stuff on all their little terminals, just like car batteries do, that can be cleaned off of there. There's maintenance stuff. Your scan tool can look at the cells in the batteries, but when they're trying to rebuild hybrid batteries, there's issues with that because you can have bad cells in there. And the right way to do it is to charge them up with a special charger, and then use a heat gun to see which one of the batteries is getting too hot, and there's all kinds of stuff that they have to do in order to do that the right way. But whenever you have to have a battery, it's going to be high. Some of your older Honda Insights could be driven if the battery and the electronics were totally offline. You could still drive them. They had a regular starter and everything, you know, on the earlier Honda Insights. They did away with that later, I think. Well, you need to stay abreast of these new systems to avoid making mistakes, and do enough research and be knowledgeable on the systems you work around so you don't have to worry about doing it wrong. Understand what kind of system is used and how it's configured. Use OE quality glass for window repairs. You can put a windshield from an aftermarket supplier in there and mess up the operation of that camera because it won't be able to see through the glass like it wants to. Watch out for any accessory that blocks sensors or cameras. If somebody has mounted some kind of little deer whistles or something and it's blocking the camera, you're going to have issues with that. Keep the tire sizes and the pressures to manufacturer specs. Mind the brakes and the brake switches. Pay attention to that. If the components need to be removed, or if some needs to be, like cameras or radar or whatever, needs to be removed or disconnected, check service information to make sure it won't need to be recalibrated or adjusted, but typically it will. You're not going to be able to get away with that. Safety systems don't need to be modified or improved. What I always used to tell my students is, you don't need to modify anybody's anti-lock brakes, you don't need to modify their cruise control, and you don't need to modify their airbag system. That stuff needs to be kept just exactly like it was built. And we're basically repairing it, putting it back in original condition. We're not going to snip and, you know, run wires around and bypass stuff and all that kind of thing. Not a good idea. Always put it back where you found it. Wire for wire, connector for connector, and bracket for bracket, unless you're guided by a recall or a technical service bulletin. Most lane departure warning and lane keeper systems are fitted with the camera at the base of the rearview mirror. You've seen those things. And lights got to be able to reach that camera. If the windshield's dirty, it's not going to work right. And replacement glass, like I said a minute ago, will adversely affect the system operation. Window tints and that kind of stuff, you know, is an issue for these. Now, some vehicles are fitted with radar-based inputs for their lane departure warning systems, and that unit will be mounted at the front. And it's a nice touch to clean that stuff up, get bugs and grime off of it so it'll work better. This guy that I knew said one time whenever he would do a tune-up on one, people would say, hey, my car's not quite running the way it used to. And he says they'd come in there, he'd go ahead and do the tune-up, clean the throttle body and all that. And if had a distributor, he'd check the timing, blah, 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 all that, put spark plugs in it. But he would check the tire pressure, and he said about half the time, you'd see the tires be about half flat. And the car's not going to feel the same with half flat tires as it does with a nicely aired up tire. So he would air the tires up and get the tire pressures right, and they would instantly feel a difference on the way that car ran, and they'd think he was just amazing, you know, when all he did was something really simple. This is the same principle. If you change anything that affects ride height, braking, steering, lighting, anything that affects the collision avoidance system is, you know, the stuff that you wouldn't even think about. You might remember this one time, I was helping this guy over at the Ford place who was a trainee, and he was trying to figure out why the cruise control wouldn't work on his Ford Focus. And he had already replaced the cruise control box and all that hogwash. And you might remember that the cruise control on those Fords is looking at the ground coming through the tail light bulbs, and when you mash the brake and it lights up those those brake light bulbs, I'm sorry, not tail light bulbs. If you mash the brake and it lights up the brake light bulb, that ground is no longer there. So if you lose both brake light bulbs, you lose your cruise. And so I always like to get a test light and hook it to hot and go to that wire coming from those stoplights, and I measured, I should see a really bright light there with my test light. In that case of the car he was working on, he had another vehicle sitting over next to it just like it that he was comparing stuff with. I'd get my test light and I says, all right, let's go. I back probe that wire that's at the cruise control module, and I checked it on the car where the cruise worked on, the good one, and it lit up that light really bright. I says, all right, now let's go to your car. So we went over there to the car he was working on that the cruise wouldn't work on, and I back probed that same wire coming from the stop lights, and the light lit up very dim. And so I says, right, this is not right. That's why your cruise won't work. So we walked back to the back, and this guy had these LED lights back there in the back. He was going to doll it up. And the guy that I was helping says, well, you know, couldn't we just put a resistor or a light or something like that? I said, no, we're not going to do that. I said, if you start modifying cruise control and he crashes and they go in there and they find out you've modified the cruise control, they're going to be all over you, and we're talking lawsuit city, man. You put this, you tell them I cannot fix your cruise control as long as you've got those LED lights on there. You need to put the original lights back on it, and then you'll have cruise again. Anyway, always to use tire pressures and sizes. This one right here, both of these tires came off the same vehicle. I was down at the tire store where I do some of my business down there, and the guy that owns it's a friend of mine. And one of these tires is taller than the other, and it was causing tire pull, but it would also cause trouble with collision avoidance systems. Basically, these tires right here both look pretty good, but one of them was a little taller than the other, and so that's a problem. All right. Now, any wheel or suspension modifications, mount a temporary spare, can affect system operation. You know, these little donuts. I don't know how many times you see people driving around with these donuts, and they just keep on driving until they wear out the donuts. You know. Brake problems such as grabbing or pulling can affect it, and it's important to assure that brake components are working right. Everything needs to be working right for this stuff to work the way it's supposed to. If you put heavy accessories on the vehicle or try to haul too much weight, that's going to affect it too. And this right here is an actual photo somebody took. It's funny to me to see somebody doing that on a Volkswagen Jetta. You can imagine how dangerous that was to drive. But a lot of active cruise control systems use a radar or laser-based system to maintain a set distance behind the vehicle ahead. See, used to, we were smart enough to where we could maintain the distance. What we do is we do the 2-second rule. We would see them pass something, and then we would pass something 2 seconds later, and that was enough distance, and that works at any speed. So if they pass that sign or something, you go 1001, 1002, and then you've passed it, then you're far enough back. That was the old standard rule. But these things right here are trying to dumb you down to where you're thinking, I don't even have to pay attention to how close I am because my car is going to take care of that for me. See how that gets people to where they can't even, if they have to drive something that doesn't have that, suddenly you're in a dangerous situation you didn't expect. But Lexus service information says it's hazardous to be within 7.9 inches, which is 20 centimeters, 8 inches, let's say that, of the device's radio frequency aperture when it's active. So, radio can mess that up too. Think about this. What about radio frequency interference from bad ignition components? That'll cause issues too. All right, blind spot detection systems. It's a good idea to clean those when you know they're on there, like on the bottom of the mirror, you got that little thing. Just clean it up, make it shiny. Surrounding view cameras, find out where they're located and try not to damage them whenever you're doing service. If you transfer equipment from an old work van to a new one, that can block cameras, so pay attention to where they are. Some cameras are in the grill, so be careful working in that area too. So watch your tire sizes and pressures, make sure the sensors are clean and all the lights work. Brakes and steering systems need to operate without problems, as always, but it's more important than ever with these systems. Always use good quality glass. Now, when you're setting the aim on detection devices like cameras and radar and stuff, you need an acceptable target. You need to make sure the car is perpendicular to the target. You need to make sure the car is the right distance from the target. You need to make sure you have a scan tool that will talk to the ADAS system on that car, ADAS system, Advanced Driver Assist. You need to know how to make all the adjustments. Now this little target thing here is from Autel up there. And notice they've got this screen behind it so that it won't get confused by stuff that's in the background, and it will only look at these little black and white checkerboard things whenever you're setting this thing up. I kind of humorously put an old 50s model car there just to play around with that. But you need training to make sure you know how it's supposed to be done too. And that's just really important too. Guesswork is only going to make a mess. So be sure that you understand all that. I hope this was helpful, and I hope you guys enjoyed it. And I really appreciate you hanging out and listening to me talk.